Welcome back to part 2 of the video. In this part of the video, what we're going to do is put together everything we learned about quadratic transformations, both the vertical and stretch and vertical compression, and the horizontal and vertical translations. So what I want you to do first is I want you to go back and think about what we learned, and I want you to fill in this little graphic here talking about what the a does to our quadratic function, what the h does, and what the k does. Write down as much as you can remember about each one, pause your video while you're doing it, and then check back for the explanation. Okay, just check and see on the a value that you did get that it reflected across the x-axis if it was negative, otherwise it's just your vertical stretch or vertical shrink. On the h value, make sure you got that it's the opposite direction. It shifts it horizontally the opposite direction, and then on the k value it goes whatever direction is indicated. So now that you've got those back in your mind, what we're going to do is practice looking at equations and without even graphing them, just knowing exactly what kind of transformation they have and writing down the vertex on it. So on this very first one, let's talk about what's happening on the transformation. So we look at x minus 2 squared. So the first thing is we don't have an a value out here. So we know that there's no reflection. And we know that there is no shrink or stretch because we have no a value. Now we look and we do have an h value. So we have an h value. We know we're going to have a horizontal shift and it's going to go in the opposite direction. So it's going to go to the right 2. So let's see, horizontal shift. We've got to the right 2 units. And then we do not have a k value on here, so we know that it is not going to have a vertical movement. So if all we did was go left and right, so we just went to the right 2 units, our vertex has only just changed by shifting right 2 units. So our vertex will be 2, 0. And we can get all of that just from looking at the equation and knowing what happens and which numbers change what. Okay, so on number 6, I want you to go through the same process. Notice this time we don't have an h value, but we do have a k value. So I want you to pause your video, figure out all the transformations that happened in number 6, and then start the video back up to check your answer. Alright, so number 6 was very straightforward. Should have seen that it is only shifting up 1 unit, and that affects the y value of the vertex because we had a k. Okay, so now let's look at number 7. And again, I want you to do number 7 and number 8, the next 2, on your own. So pause your video, do number 7 and number 8, and then start the video back up to check your answers. So the more you practice these, the faster and easier it'll get to see what's happening with your quadratic function. Now number 9 and 10, we've added back in an a value. So I want you to pause your video to do number 9 and 10, and then start it back up for the explanation. Okay, so just double check your answers on 9 and 10. Notice on 10, since we had no h, no k, our vertex was back to 0, 0. All we did was a compression. So now let's look at number 11. So we have been comparing to the parent function, but now on number 11, it wants us to compare 2 functions together. So first thing you need to know is just kind of how to read this. So what we've got here is function f is this whole thing. Function g says take function f and subtract 7 from it. So what really is happening is function g is the whole function f, this thing right here, minus 7. So that whole thing right there, minus 7. So really, what are we doing to function f? The only thing we're doing to function f is we're translating it down 7 units. So that's what's happening to it. So go ahead and pause your video and write that in and see if you can figure out the vertex of g, and then start it back up for the explanation to check your answer. So hopefully as you were looking at this, you could say, okay, well, our vertex on f, we can always start with this one. And we know that it didn't have an h value, so our h is going to be 0, and our k value is 2. So we know our vertex. Then we take the information we were given that we shifted down 7 units. So going down means we're affecting our y value. So when we subtract or go down 7 units from positive 2, we end up with negative 5. Okay, so the last one, number 12, is an application question. So I want you to pause your video. It's going to take you through a lot of things that you've already learned. Pause your video, work all the way through it, get to the final answer, and then start it back up for the explanation. So from reading this, I knew that the height, when the ball hits the ground, the height is 0. So as I made my quick little table, I knew I was looking for a 0 in the y column. So I set up my equation, equal to 0, and I needed to solve it. So I took out my greatest common factor, and at that point I realized I had a difference of perfect squares, t squared and 5 squared. So I went ahead and wrote it out in factored form and set each factor equal to 0. When I got to the end, I had t equals negative 5 and t equals positive 5. Well, there's no such thing as negative time, so my answer is 5 seconds.